talking about a very interesting topic that even many electronic guys are not really aware of. And that would be, why is capacitor essential to be fitted across the diode? In other words, you get the diode and then you fit the capacitor across the actual diode in parallel. And right at the beginning, the answer is yes, it is important, and it must be sort of fitted across the diode, and which I will demonstrate just now. Very simple sort of setup. I used one ordinary rectifying diode. It can be any diode type of thing for a demo, but nonetheless connected to my setup, and basically that's what it is. And I've got a decade capacitance that I can actually vary and just connect it and disconnect it across the capacitor, and then I will display across on the screen the actual difference, what is actually happening. Okay, let's start from scratch. Right now it is connected, as you can see, and this is a typical sort of half wave rectification. You can see only half of the sine wave. The bottom is missing, and the reason why, because it's only a single diode, so it's perfect. Now the point of interest is this one over here. Now I don't know if you can see the actual little spike, and then what I will try to do is I will try to increase the resolution, okay, and so you can see it much better. You can see, okay, I'm just trying to, okay, can you see the actual spike is getting, okay, bigger and bigger and bigger. So right now, let me just do this. Just increase a bit of a signal. Okay, now you can actually see, and this is of very much of a concern, and you know, for protection of the diode, for and this very sharp sort of rise and this ringing, which is you know, interfering with the actual with the operation of many electronic circuits, because these spikes, they do carry sort of energy within them, and they create the magnetic fields and introduce a hum, etc., and so on. And you know, the steeper and the sharper and the higher the amplitude and the higher the frequency, the more interference, and it can actually create a lot of noise in many electronic circuits, and it can jam the actual microcontrollers, and more importantly, you know, it can destroy the actual you know, the actual diode, you know, if it does not have a capacitor across it. Now let's start from scratch. What I'm gonna do right now is, you can see this is a diode without the capacitor. Now I'm gonna take and I'm gonna connect a decade sort of, and I'm gonna connect it across the capacitor, I mean across the diode. Okay, I'm gonna do it this way and watch what actually happens. Okay, now the diode is on, now the diode is off. Again, the diode is got the capacitor right now across it. Now I'm gonna keep on decreasing the value of capacitor. Now I'm increasing, and you can see the amplitude is getting shorter, smaller, peak to peak, and most importantly, the frequency is getting reduced, and the ringing, although it looks sort of a bit bigger or whatever, but it is in actual fact smaller, and it's a sort of a more gentle over transition from this point to that point. it's not the abrupt and very sharp and steep. And that is the aim of actually of this capacitor to be fitted across the diode. Now, probably you will ask, but what value capacitor do we use? Okay, I'm increasing the value, and you can see it's becoming less and less steeper and lower frequency sort of actual interfering spike. Now, you're going to probably ask, but where do you actually, how do you determine the value of this capacitor across the diode? Well, these are lengthy calculations, but for me it's very easy. I just zoom, as I said, let me go onto the beginning of the waveform. If you look at it, okay, what I said, it's a halfway rectifier, and I just zoom on this particular point on the trace, and then what I do is I expand it, measure, and then keep on adding the capacitors. Okay, let me just do this. And I keep on adding the capacitors. Okay, now that's without a capacitor connected. Now it's with a capacitor connected. And I reduce it to a particular point where I basically, no matter what capacitor you actually fit, let me start from beginning, no matter what value capacitor you fit, you will not be able to eliminate this ringing and these spikes because of the TRR, which is a reverse recovery time of the actual diode, any diode, but it's a fast switching or rectifying and so on. So, but the aim of and the purpose of fitting capacitor across the actual diode is to reduce the actual amplitude of these spikes, to also to make it smaller, smaller step, smaller sharpness, lower amplitude, and much lower frequency, which would be then good enough, like it is right now displayed on the screen, not to be a problem to interfere with any sort of electronic circuit where the diode is supplying or connected to. Okay, and more so, it actually protects the actual diode itself, protects the diode. More so in very fast switching circuits where the inductive loads or capacitive loads are sort of predominant and things like that. So now, why do we get these and these spikes and so on? Well, in this pamphlet I have explained because of the depletion layer, and this is what a diode actually looks inside if you look at it. Okay. Now, the depletion layer is basically a region near the junction of the P and N. So that is the actual depletion layer, and it's free of charge carriers, the electrons and holes. Okay, so it creates like a barrier between the main P and N junctions. Once you forward bias the actual diode, the electrons, they start flowing from here into and start recombining, and the depletion layer becomes smaller, and they start actually flowing and start recombining with the holes, and the holes start moving across the actual barrier. And now these minority carriers, they actually within the actual diode, they actually create an electric field, which actually can be very detrimental to many electronic circuits, creating noise, as I already explained, jamming the circuitry, microcontrollers, interfere with the operation in a simple sort of terms, interfere with the operation of the electronic circuits. And it can be troublesome. But by putting a simple capacitor across the diode, you actually lower to an acceptable level, that you can sort of, how can I put it, you reduce the, the smaller, make it a smaller step and smaller sharpness, lower amplitude and lower frequency. And that, if it's increased anything from like 20% to 50% and so on, would be good enough to solve the actual problem of diode noise generated by the depletion layer and recombine and movement of the electrons between the depletion layer. Not to be a problem, and also in turn to protect the diode. So yeah, I think I explained it in a very sort of nutshell, but basically the capacitor does quite a number of different things. One of them diode protection, next one back EMF protection, rectifier smoothing, type of thing. Because you must realize one thing, the capacitor across the diode, it charges up when the voltage is high, and it discharges when the voltage drops, filling in the gaps, of course, because it's a halfway rectifier, as I explained on the screen, and providing a more constant DC voltage and less induced noise due to the depletion layer and of the diode.